To deduce the Newton's first law from the principle of momentum, you must know the equation for conservation of momentum, and that equation is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. You remember this equation, right? Okay, so now you make use of your science, your maths ideologies that we group like terms, right? So m1 u1 minus, we move this here, right? So to be minus m1 v1, right, is equal to, now we move this to the other side, right? Okay, so we have this, our m2 here, to m2 v2 minus m2 u2. You know, this is what we just move here, right? Okay, now we can proceed. Now we factor out m1 because we have similar terms here, so we'll factor the m1 out, which will be m1 open bracket. Now we have u1 here minus the v1 here, v1, then we close the bracket. This will be equal to, we have m2 here, m2 here, so we have like terms there, so we bring the m2 out and we open bracket. We have the v2 here and u2, so we just write v2 minus u2, right? Okay, now that we have this, we can say that u1 minus v1 shows that there's a change in velocity, right? So we can just say, and this we can see that this is the negative aspect of the change, because in the normal sense it's supposed to be v1 minus u1, but here we can see it's quite the opposite, right? So because it is the opposite, right, because it's the opposite, we will say that let u1 minus v1, right, equals negative, because it's opposite, so we say negative change in velocity, right? Okay, and then so negative change in velocity 1, and then we can see here, this one, that's also negative, that's also a change in velocity, right? So we would say that let the v2 minus u2 be equal to what? Change in velocity 2, because we can see that we have the final velocity here minus initial velocity, so that means it's what? It's change in velocity, right? And then we can see that with the u1 minus v1, that's also a change in velocity, but it's quite the opposite. That's why we give it a negative, right? I hope you understand that part. If you don't, comment in the comment section and I would talk to you personally and take you through again. Okay, so now that we know the negative change in velocity 1 and change in velocity 2, we can then proceed and say that we can just substitute. So we substitute this right here. Then we substitute this here, right? Okay. So we can then say that M1, then we open brackets, then we substitute. So it will be negative change in V1, right? And this will be equal to M2, and then into bracket, we substitute the V2 minus U2, which is what? Change in velocity 2. We substitute that here. Okay, so now we have a complete equation, and then we can just say that we can divide both sides by changing time, right? So let's divide both sides by changing time. So you can just say divide both sides by changing time, right? So we would have negative m1 change in velocity 1, right, is equal to m2 change in velocity 2. Then we divide them by what? Change in time. Right. Okay. Now let's move to the next page. So since we have that, let me write it here again, which is changing m1, m1, negative m1 change in velocity 1 is equal to m2 changing velocity 2. Now we said we'll divide them by changing time, right? So we can then say that we can see here that changing velocity over changing time is for acceleration, right? So we see here that changing velocity 1 over changing time is the same as what? Acceleration. So we can then say that we can then substitute the A, which is acceleration, which is the acceleration, into the equation. So we substitute this A here, and then we substitute it here, right? I hope you understand me. Okay, so now we can just say that negative m1, then we substitute the A, right? So it will be A is equal to this, which is m2 A, right? And we know that force, right, is equal to what? Mass times acceleration. And that's what we have here and here, right? So we can just say that negative m1 A is the same as what? Negative F1. That's force is equal to MA. But because there is a negative sign here, we have to bring the negative sign here. Okay. And then, so that is for this one. And then let's do for this one, which will be M2A, which is the same as what? F2. Because there's no negative, we add no negative, right? Okay. So then we can just say, we can just substitute them into the equation, which will be negative F is equal to negative F1 is equal to F2. Okay. So that's your final answer, and that is Newton's third law. It says, to every action, there is equal and opposite reaction. So this equation shows that here there's a negative sign here, here there's a positive sign here, so they go both ways. That's what basically Newton's third law means. Thank you for watching. Bye bye.